Hi, welcome to this tutorial on proving trigonometric identities. And in this example, what we've got to do is prove that sine A all over 1 plus cos A plus 1 plus cos A all over sine A is identical to 2 over sine A. Okay, so how are we going to do this? Well, first of all, we should put down that we are going to give a proof. So let's just put the proof. And what I would always look at is the side that has got the most terms on generally. And generally speaking, it's often the left-hand side of the identity. As you can see, we've got 1, 2 terms here. These look a lot more complicated than this term here. So I'm going to start with the left-hand side. Some people just write LHS for the left-hand side. You can do that. I'm going to take that out though. I'm going to just write this in here. Okay, as sine A over 1 plus cos A. Okay, it's a bit longer to write this out, but I just generally prefer setting it out in this style. Okay, now what do? What we do is make sure you put your identical sign down, and we look to try and simplify these two terms with the aim of gradually reducing it to 2 over sine A. Now in questions like this, when I've got two fractions and I see that I've got to get one fraction here, this immediately gives me the clue to put it all over one common denominator. So that's what I'm going to do here. Just put one big line down here. And as a lowest common denominator, it will be 1 plus cos A multiplied by sine A. So I'm going to just reverse that though as sine A multiplied by 1 plus cos A. Now, what do I need to multiply 1 plus cos A then to get this denominator here? It would be sine A. So I'd need to times top and bottom of this fraction by sine A to turn it to an equivalent fraction with this denominator. So that's just going to be sine A times another sine A, or sine squared A for short. And when it comes to this fraction, to turn it into a fraction with this denominator, I would need to multiply the bottom by 1 plus cos A. So I need to times the top as well by 1 plus cos A. So that's going to be plus 1 plus cos A times another 1 plus cos A. In other words, 1 plus cos A all squared. Okay, now where do we go from here? Well, I notice that I've got my sine A already on the bottom here, so I'm going to leave that alone. I've got the 1 plus cos A. I'm not going to do anything with that. I'm not going to expand this bracket. So what I'm going to do is just tidy up the top. So we'll have the sine squared A term like that. We're going to expand this square bracket. So we will have 1 times 1, so that's going to be 1. We'll have 1 times cos A, which is cos A, plus another 1 times cos A, so that's going to be plus 2 cos A, and then we're going to have the last term cos A squared, so cos squared A, and that's going to be all divided by sine A multiplied by 1 plus cos A. Okay, put the identical sign down again directly underneath. Now we've got sine squared A plus cos squared A. You should know that as a standard identity. I'll just mark it over here, alright? Sine squared A plus cos squared A. Do you know that one? It's identical to 1. So what I can do is replace that then with a 1, add it to this one here, and what I've got is 2. 2 plus and then 2 cos A. Alright, and that's going to be divided by sine A multiplied by 1 plus cos A. Now, what are we going to do next? Well, I can see that 2 is a common factor on the top. So I can pull out 2 as a common factor, and we've got 1 plus cos A. And that's all divided by sin A multiplied by 1 plus cos A. And now we've got a common factor, both on the top and the bottom. So we can divide top and bottom by 1 plus cos A. So they cancel themselves out. And what we've got is our final answer, 2 over sin A. So we've been able to prove it. So just put that down neatly here, 2 over sin A. Alright, so that's how I would suggest anyway that you always set out a trigonometric identity. Alright, make sure you put your identical sign down here and just try and follow through these stages. Now, proving trig identities is tricky for a lot of people, so give it time, alright? And just keep experimenting, and sooner or later you should find that you are able to do it with relative ease. Okay?